Hi, and welcome to an introduction to mobile development with iOS. My name is Mike Rogers, and I'll be your instructor. Just some background on me. I've been developing applications for over 17 years, and I got into mobile development back in the days of Windows CE and the Palm OS, and actually built some prototype applications for customers, and that's where I got it in. Otherwise, I'm normally developing web apps or desktop apps for companies. And then, the types of apps that I'm interested in these days are ones that drive revenue to existing companies, ones that are useful to the end user, but also bring them closer to connecting with brands. So do me a favor, in the comments section, leave me, a description of your name, what your development experience is, and the types of apps you're interested in, and we can connect on that. So the goals of this introductory workshop are to give knowledge of the iOS, give you some basics of how it's constructed, how it's put together, how it's layered, to give you a better understanding of what it's going to take to build applications. And then we'll begin laying the foundation for building your first apps, and it takes time to become a master. But coming out of this, we'll develop a very simple app, and you should be able to play with the iOS, Xcode, and the SDK yourself and make some very simple applications. So throughout this course, we're going to go through an overview of iOS 7. We're going to talk about the SDK and its frameworks and what it's comprised of. We're going to go through Introduction to Xcode. And then we'll talk about MVC, or Model View Controller, which is the primary design pattern that iOS follows. And then we're going to go through getting started with some Objective-C, and this will be new for a lot of you. Objective-C is something that has actually been around for a while, but made its way into Next Step, which is the precursor to OS X, and it's used as the primary language for developing iOS applications, as well as Mac desktop applications too. And then we'll go through creating our first iOS app. So I'd like to start giving a brief introduction to object-oriented programming. Objective-C is an object-oriented language. It was developed to model Smalltalk, another popular object-oriented language. And when you're programming object-orientedly, one of the benefits is you try and create things that model the real world. So what we do is we create things like a class, and the class describes the data and application operations that we're going to create. Think of it as kind of a template. It's the raw instructions that the computer will use. And then an instance is a instance of the class. Basically, we make a copy of the class, and then that's what we operate on. And that's what holds our information. That's what performs business logic functions. Maybe if you're making a calculator, it's what adds numbers, all of those things. An instance is the class in action. A method is a behavior that's encapsulated inside of a class. So methods usually do some sort of data operations with data. Instance variables are ways for us to hold data. They're like little cubby holes for information that are stored within inside of an instance of a class. And then we have properties. Properties encapsulate variables and protect them behind special methods that are called getters and setters. And we'll see how that works a little while later. So here's a very simple object-oriented code example. We have a class called a car, and that class defines some properties, such as gas in tank, which tells us how much gas is remaining in the tank. And then we have some methods on it, such as accelerate and stop. And those are methods that we can call that'll tell this software version of a car to do certain things. And then an instance of a car might be my personal car. So when you think about the real world, there are lots of different types of cars. And then when you actually manufacture a car, that's the actual instance of the car. So you could think of it slightly that way. The class is kind of the blueprints for the car, and then once it's manufactured and running, that's the instance. Some other benefits to object-oriented programming. One is called encapsulation. This conceals the details of the business logic and the decisions that you make as a programmer, and allows people to use your class without having to know anything about the internal ways that you're handling things. So that's very important, similar to, again, we'll use our car analogy. When you go and buy a car, you could buy parts such as an alternator or a spark plug and things like that. You don't necessarily need to know exactly how that spark plug was put together inside of itself, but you can know where it plugs into and how it interacts with other pieces of your car. And that's one of the benefits of object-oriented programming. Imagine if you had to build your own spark plugs every time. That's why we want to make sure we can encapsulate code objects into classes and reuse them a lot. And then there's things called this term called polymorphism, and that's a fancy computer science word. Basically, it means we can take any class and extend it and add our own functions, data, and operations using the basic properties of the original class and add our own. It lets us customize that class. Thirdly, object-oriented programming gives you a way to better organize your code. For example, it allows you to model the real world. In our example, if we're making let's say a game about cars, we'll have a car class that represents one of the cars that you could drive in that class. Or we'll have a class called invoice if we were making some sort of e-commerce system. So it lets you program and deal with objects similar to the way that you can deal with them in the real world. One of the primary design patterns in iOS is called Model View Controller. Think of a design pattern as a best practice or a specific way of doing something over and over again. It's almost like a recipe or a style that has been developed that allows us to accomplish tasks in a way that's consistent over time. So in the model view controller pattern, we have something called the model. And the model is what holds all the data and business logic of your application. This is where you put most of the processing and data handling and parts of your application. The view is the user interface, and it's what the user interacts with. So this is everything that would show up on screen when we're developing iOS apps, the buttons, the sliders, text boxes, keyboards, all of that is part of the view. And then finally, we have the controller. And it's the controller's job to send and receive input and output with the view. So when we want to display some information on the screen, the controller will go to the model, get some information, and then send it to the view so that it can be presented on screen. And then just the opposite, when something on screen happens, a user types or touches part of the screen or makes a gesture, the controller will take that information and send it to the model, ask the model to perform some sort of processing usually, and then return it back and send the output of that process to the view. So what this lets us do is each individual component of the application becomes nicely packaged. And this lets us kind of put things together like Legos. So we've always got the model talking to the controller. And this is important because you don't want the model to know about the controller. You don't want the model to know about the view. You just want your model to focus on what data it needs to contain and what operations it needs to perform on that data. So, for instance, if you think about the way a physical calculator is made, we have the buttons and the screen and the plastic case that are all part of the calculator. The model is like the internal chip whose job it is only to add and subtract and divide and multiply. And that's where all the business logic is, and that's where the brains or the math happens of that calculator. And then you can think of the controller as the wiring between that chip that does all the math and finally the view, which is the screen where you see the numbers, the LCD screen, the buttons on the calculator. Those are all part of the view. And together, all those parts plug together like Legos and give you a working application. So some of the additional benefits of Model View Controller: it separates the logic and data from the user interface. And today, the number of devices is growing. We have, the iPad Air, we have the iPad Mini, we have the 5S, and we have still the old 4S in play. So we need to sometimes be able to build one application that works with multiple user interfaces. And using Model View Controller allows us to do that. We can keep all the same controller code, we can keep all the same model code, and then simply change out the view to present things differently, like let's say on an iPad, than you do on an iPhone. And then testing becomes a lot easier when these components are separated. So you can write code that will test itself, or automated unit testing, that will test the functions of your model and make sure that they're behaving properly and satisfying the needs or the business logic that you imagined they should. And that leads to a higher quality product. So the iOS 7 technology stack is made up of, at the bare minimum, it's Core OS, which is a Unix-based system. Then there are the core services, and core services make up things like the threading manager that allows an application to do more than one thing at once. It makes up the core access to things like the address book, or networking, or access the cellular network and know whether or not a user is on the cellular network. So it's really low-level, detail-oriented things. The media layer is next. The media layer provides you all the functionality for recording video, playing back video, recording audio, playing back audio, as well as managing photos, taking new photos. And finally, on top of all that, we have Cocoa Touch. And Cocoa Touch is what comprises the user interface, all the specialized layers that are within iOS, specific to touch and gestures and elements of that sort. So Cocoa Touch is where we really separate iOS from the other core services that are also part of the Mac desktop. So again, Core OS comprises threading, networking, the address book functionality, core location, geolocation. These are all low-level programming pieces. Next is the media that deals with audio, video, and images. And then Cocoa Touch is what makes up the user interface and the iOS-specific information. And you'll see two primary code examples today, and you'll notice that a lot of the classes have a prefix, UI, and then the names of their classes. And this is called the UI Kit framework. It contains all the elements for the user interface that you always see on screen, buttons, text boxes, everything you see in every basic or classic iOS app. And it also has things like event handling and touch handling. And the next thing you'll see a lot of are the foundation classes. These are utility and collection classes, standard classes that every language has, such as string manipulation, arrays, dictionaries, all the basic data storage pieces that other things have. And these are all wrappers for lower level APIs within the SDK. But all you really need to focus on is the foundation classes and the UI kit. So Objective-C is a strict superset of C, which means that anything you could do in C, you could do in Objective-C. Now, not too many people program in C anymore because it's not a managed language like things like .NET and Java. Just makes you have to be a little more aware of what's going on under the hood in terms of memory and utilization. It's based on C and Smalltalk. Smalltalk is an object-oriented language that excelled for a while. Another important difference with Objective-C and iOS is that there's no garbage collection. So when you're dealing with things on the phone, you need to be very careful about memory leaks and leaving memory hanging. And then finally, Objective-C does have a dynamic runtime, which gives you a lot of power, like other dynamic runtime languages, such as JavaScript probably being the most popular right now. But it also, because of that, has some major gotchas that you have to keep an eye on, and we'll talk about those. So in Objective-C, the decision points and code really model C, and if you have worked with Java, you'll also recognize a lot of the constructs. Since we are dealing with C, one thing that you may not have ever even dealt with are things called pointers. So in most modern languages today, we have references to objects. Since Objective-C is C-based, it has pointers, and a pointer is a variable that holds the address of a specific place in memory. And that's how you access elements that are in that memory space. Two things are important here. One is that you'll see in this example here that we have to allocate space for that memory and then initialize the object into that memory space. So it's kind of a two-step constructor process when you're dealing with Objective-C. Objective-C has the notion of instance methods, and these are methods that belong to a class and are accessible when you have an instance of the class. They can operate and see instance variables that are part of that class and deal with them. And you'll notice here that they're prefixed when you define the function with a minus sign. So it's minus sign, return type, and then the name of the function. And then they have class methods, and class methods are your static methods. So, and those are denoted by a plus sign. Now, some people confuse this and they think, oh, minus must mean private and plus must mean public. Objective-C doesn't have the concept of public and private. Since it is a C-based language, most things are defined that are supposed to be public are defined through the header files. And then things that a programmer does not want to expose to the outside world are not included in the header file. And you'll see about the header files as we get a little further in. The Objective-C dynamic runtime has a unique concept or pattern called receiver message. And in other languages, when you call a function, the compiler usually changes that into a routine that jumps to a point in the code where that method is, and then executes it and then returns control back to the code that had initiated that. In Objective-C, it works slightly differently. The runtime, you give it the name of a receiver, which is an instance of an object, and you give it what's called a message. And that message is sent to the receiver. The receiving object looks at it, looks for a method that matches that message name, and then executes the code. Now, the good thing about this is you can dynamically, at runtime, manipulate this and send different messages to live objects that maybe you haven't coded before. So that can be very powerful, and that's where the dynamic runtime of Objective-C really shines. However, the downside to this is when you send a receiver a message, if it does not implement that message or have a method that implements that message, it will crash. And it's a hard crash. The whole app will die. So you have to be very careful. The second and third lines here illustrate how Objective-C handles parameters. So in our second one, receiver message : argument. So in this second line, this is a method call with a single argument. And then the third one, you'll see some really interesting syntax where we have add this : argument 1 to this :argument 2. So in Objective-C, it thinks of the message as that entire section from add this all the way up to argument 2. A little tricky, a little something to get used to, but it's with the way they've chosen to lay out their parameter system, and what you end up with is actually named parameters, which actually can work pretty well. So here's just a quick code sample of how using our example car class might go. I define a car pointer, and I ask the object Joe, Joe represents a person in this case, for its car instance. So that gives it back to car. And we check, we ask Joe's car, we send it a message, we say, has gas. And that Joe's car instance will then receive that message, look to see if it has a method named has gas, and if so, execute it. So in this case, it would execute a method, and that method returns a bool. You'll see here it says equals equals no, capital N-O. Those are compiler directives. The code style for Objective-C, rather than using true or false, usually uses no and yes to make things a little more readable. And then the next couple of lines within that if block just illustrate more function calls using the receiver message pattern. So Joe's car, drive to station. Joe's car, fill with gas at pump number 2. So those messages all must exist. And when you're coding things like this at compile time, everything works. The compiler will tell you if that message corresponds to a method that's on that class. However, you need to be careful if you try and get into dynamically sending messages to classes, that you first have to ask the class if it responds to that message and then decide whether or not to send it. Because again, you need to watch out if a receiver does not implement a method to respond to a message, it will crash. Another special construct of Objective-C is the ID type. And the ID type represents any Objective-C object. And this is different than a lot of things because it's really just a catch-all pointer that's untyped and gets typed at runtime. So you want to be careful with how you use it, because obviously if you attempt to manage an object that isn't what you think it is, the application will most likely crash. So mainly we're using this any object when we're passing around classes that might delegate work to another class, or usually when in the constructor of any class. And then if it can, the compiler will try and check those types at compile time. If it can infer what those types are, it will attempt to check it. But it can't always know, based on the context of your code, what type that variable might be. So you have to be careful of that. NSLog is a handy routine to use while you're coding to output the status of certain variables, let you know where in the code you are. It's also useful for debugging and outputting the status and the values that are currently in operation. It works like printf in C, where you can give it a string followed by a comma-separated list of parameters. And inside that string, you can use the standard printf formatters. Here we have an example. %f is for a floating point. %d is for a decimal number. And if you want to output an object, you can use %@. And for objects like NSStrings, that will output the content of the string. For other objects, you need to make sure that there is a description property created on the object that will then output what you'd like to see. Next, we'll dig into Xcode and look at all the tools that are given to you and give you an overview of the user interface and what elements you can use for what purposes. So Xcode is an integrated development environment, meaning it gives you management of everything from your source code to resources like images, audio, video. your user interface, and other assorted bits of code. It does have Git built in, a popular version control software, and gives you access to other things such as SVN, also allows you to deploy applications to the Mac desktop as well as the mobile apps and deployment to the phone. So let's get started. We'll look at Xcode. We're going to do that by creating a new project. We're going to go to the File menu and choose New Project. And we're going to create an empty project called First Project. So I'll go to my toolbar and I'll launch Xcode. And we'll see it, bounce as it launches. So once Xcode is launched, we can go to File, New, and we're going to choose a new project. And what comes up is a dialog that gives you an assortment of project templates that you can use in your application. The master detail application is very similar to something like if you've ever used the Mail app. It gives you what's called a navigation controller, which lists records. And then when you select a record, it opens up a detail pane for you to work in. OpenGL games are 3D driven games. OpenGL is an open graphics 3D engine that you can use. A page-based application is something similar to the weather app on the iPhone. If you've ever looked at it, it gives you one page per city with the weather, and you could swipe left and right to get to the other cities to see what the weather is. A single view application is a good place to start. That gives you a single view on the user interface and starts you off with a single controller. A tabbed application gives you the tab bar at the bottom with a couple of views to start you off. A utility application is kind of an older application. I haven't seen many people use it these days. The original weather app was a utility application where it's got two screens, one on each side, if you will, of the main user interface. And when you tap a little info button, it'll flip over, usually to give you some settings. Again, it's very simple, really only used for extremely simple applications. There's the empty application, which gives you just the real basics. You have to add most of what you need to the application yourself. And SpriteKit is new as of iOS 7, and it's a game engine similar to Cocoa 2D, but built by Apple and integrated into Xcode for you. So I'm going to start with an empty application and click Next. And now here we'll give it what's called the product name. I'm just going to call mine First Product. You can give it your organization name. Mine's Brainloaf. And then some sort of company identifier. Usually it's reverse domain notation. So com.brainloaf as opposed to brainloaf.com. And then you can see here in the bundle identifier, it takes this product name of First Product and appends it to the company identifier to come up with something called a bundle identifier. The bundle identifier must be unique to your application, especially when you are deploying it to the App Store. That's very key. Since Objective-C is C-based, it does not have the concept of namespaces that many people use in languages like C# or Java to organize code. Instead, we have to use an old school technique called a class prefix, which are just a few letters that get prefixed onto the name of any class. And we do that so that different libraries do not collide with each other. For example, if I built a class and called it Home, and then you integrated my third-party library with a class named Home in it into your application, and then you created a class named Home, when you went to go compile, the compiler would be confused about which class you're actually referring to within your code. So you always have to give it a prefix. It's best practice. That way, if you ever mix code from different sources, your prefix should keep you within, your own virtual, if you will, namespace. For the purposes of this instructional video, we're going to use the iPhone. Now, you could choose an iPad application or a universal application, which includes all the same stuff, except it gives you a user interface for both the iPad and the iPhone when you're making a universal app. And then core data is something we won't deal with in this introduction, but that's Apple's native object relational mapping tool that you can use, and it's built into a lot of the core interface elements like the table view to give you fast access to information on disk. So leave that unchecked for now. Then I'll click next. And now we just pick a place to save it. So I'm going to save it in my standard working folder. And now you'll see the project opens, and we've got it here on the left side in the Project Explorer. That's the first little button here on the left. And you'll see we've got something called a BL-AppDelegate.h and a BL-AppDelegate.m. The AppDelegate class is kind of the center point of your application. It's the very first thing that gets started up that you can actually add code to. Also, you'll notice here, since this is the first time we're looking at code, we've got a .m file and a .h file. So Objective-C uses the file extension .m. And then since we are in C, all of the method prototypes and header information is contained in the .h file. It's a lot different than many modern languages today where it doesn't deal with having to have a header file. But since Objective-C is C-based, that's the way the compiler works. Under supporting files, we've got some other information here. A plist file, which contains a lot of the settings for your application. To start out, we won't modify anything in there, but that's where you can do more advanced things. There's the main.m file. So if you're familiar with C, every C program somewhere must have a method in it called main. And that's what the operating system uses to execute and kick the program off. So if we click on this main.m, you'll see we do have a pretty standard C main function. It takes some arguments, as well as a list of parameters that go on the command line, if you will. But definitely a little old C holdover. You don't have to worry too much about that, and you'll never have to touch this .m file. And then, as part of every Xcode project, Apple has been including template files for unit testing. And this is great. I'm a big proponent of test-driven development, writing tests before to help you decide what the design of your code should be, what the design of your classes should be as part of your development. And a lot of people look at that as, oh, I'm adding extra time, I don't need to do that. It's just a good practice. We won't cover it here, but it is available and built into Xcode now, which is very handy. So I'm going to go back to our BL-AppDelegate.m file, and you'll see there's a whole lot of boilerplate code that's part of the application template. And there's a whole series of, each one of these are event handlers that are overriding methods in something called the application delegate protocol. For now, we won't deal too much with protocols. Just these functions get called at certain points in the application. So the first one you'll see here, this did finish launching with options method. This gets called once your application has been loaded into memory and has started. And what's unique here, and I'll just do this to illustrate to you, we can use that function that we just talked about, nslog. And I'm going to write just a simple log message. We'll use the old standard, hello world. And then when this application launches and this method gets called, nslog will cause something to be output to the panel down below. And I'll show you that panel. We can find it by clicking in the top right corner here, this little button. This area will come up. And in this area here, in the center right, is what's called the console or the output window. So in order to illustrate this, when this application runs, this did finish launching with options method will be called. And I'm going to insert a call to nslog, that little helper function that we talked about. And I'm just going to use the old standard. I'm going to have it say hello world. And that's just going to write a string out to the console. So I'm going to save that and run it. And that application should launch, and then when it runs, it will hit this line. It'll execute that NS log, which will write out a message here called Hello World. So when you click the play button, that'll run your application, and then it'll also launch the simulator to run your application within. And it's launching. First launch usually takes a few seconds. There we go. So up comes the simulator window, and it'll be blank. Actually, it'll stay blank the entire time because I didn't put any user interface on here. And then we can see, okay, so that's launched. And then in our console window here, you will see Hello World. So that's a result of this NSLog line that I threw in that function. You also see some other things about warning us that we don't have a real root view controller. That's because we didn't add any user interface elements or anything. But you can ignore that. So I mentioned quickly that the first element on that left side of the screen in Xcode is called the Project Navigator. And you'll see there's a series of those little icons because there's multiple navigators within Xcode. So we'll go through a few of them. So the Project Navigator is the first, and this is where you can see a tree-based outline of all your source code and frameworks that are included in the project. It's basically your view of everything that's in the project collection. The second is the Symbol Navigator, and this is where it'll show you a tree-based view of all your classes and objects that are currently in your application. Third is the Search Navigator, which is completely mislabeled. So I briefly mentioned that the very first panel that you see that includes your source code is called the Project Navigator. There are a series of navigators in Xcode divided into sections, and you'll use them for different purposes as you program. And they each provide a different view of the project. So why don't we go back over to Xcode and we'll take a look at these. So back to our first project, our first navigator is the Project Navigator, where we can see all of our source code, the frameworks that are included, the unit testing project, and the product output. Now, we haven't talked about the products output, but products are the actual application or the output of all your source code. So based on the basic template, we have two items here. First product.app, which is the application itself that you're creating, and then first product test.xctest. And that's an Xcode test library that you can then run your unit test through the test runner. We won't be dealing with that in this project. The second navigator is the Symbol Navigator, and here is where you can see a graphical visualization of your classes, denoted by the C, methods that are in those classes, denoted by an M, and then P, properties within those classes. So this is a handy way to quickly remind yourself, take a look at the structure of objects as you're writing your code. The third navigator is a Search Navigator. So if I do something like, let's search for void, there should be plenty of references to void. This will show you first the file name and then all the places that void exists. And if I click on one of those lines, it will jump it to and highlight that section of code. The fourth navigator is the Issue Navigator. So if you have any syntax errors or problems in your code, they'll show up here. So I'm just going to put in some garbage into our code, and then we'll see here when we compile or automatically as Xcode compiles, those issues will be listed here. If you click on one or double click on it, well, double clicking will bring up a window. If you simply single click on it, it'll jump you to that line in the source code where you can then clean up the code and fix that compile error. The fifth panel are the product tests. So this is where you can run unit tests from if you're dealing with unit testing in your project. This is the debugging explorer or navigator, and it shows you how much CPU your application is using and how much memory it's using over time. So these could be very handy indicators if there's something seriously wrong with your application. Then there's the breakpoint navigator. Any and all breakpoints throughout your code will appear here. I'm just making a few breakpoints. You create a breakpoint by clicking in the margin next to a line number to create that. And if you right click, and you can delete breakpoints. And actually, if you don't have those line numbers, you can get them by going to the Xcode menu, Preferences, and then flipping to Text Editing. And down here in the Show area, there'll be a checkbox for line numbers. Make sure that's checked off, and that will show you the line numbers within the code. And then finally, this last navigator, I don't use too often, but it's a kind of a history or a log output. So every time you compile, every time you run some unit tests, things like that, this will remember the state that it was in. And you can look at, oh, okay, so here was where a build failed, and I could see what happened. Oh, NSLog was wrong. So it's handy to kind of look back at. I find I don't use it too much as I'm developing in the real world.